Good day everyone. In this video, we will demonstrate the basic principles and procedures of gel electrophoresis, a standard laboratory technique for separating and analyzing DNA fragments. Proper use of personal protective equipment is essential throughout the procedure to ensure safety and prevent contamination. By the end of this presentation, you will understand how DNA samples are prepared, loaded, and separated and interpreted using a DNA ladder.
For the procedure, we begin with agarose gel preparation. First, we weigh 1.5 grams of agarose and dissolve it in 100 milliliters of buffer. Then heat in the microwave for about 1 minute until the solution becomes clear, avoiding bubbles. Next, set out a casting tray with a comb. Once the solution cools to about 55 degrees Celsius, add 5 microliters of DNA stain and mix gently. Pour the gel into the tray about 6 to 7 millimeters. Remove bubbles and allow it to solidify for 15-30 minutes. Once firm, remove the comb. The gel is now ready. This is important because the gel acts as the matrix that separates DNA fragments based on size.
Next is preparing the DNA samples and ladder. First, pour each into their respective tubes. Then add 5 microliter of run-safe stain so that the amplicons and the ladder are made visible under the UV light. And then add 10 microliter of glycerol to increase density, allowing the samples to sink into the wells. And then finally, vortex again and set aside for loading.
Sample loading begins by mixing each DNA sample with loading dye. This dye is then stirred in the buffer, ensuring the sample sinks neatly into the wells, and it contains a tracking component like bromophenol blue so we can follow the migration of DNA during the run. When placing samples into the gel, use a fresh pipette for each one to avoid contamination. Lane 1 is reserved for the DNA ladder, which serves as our size reference, while subsequent lanes hold our patient or experimental samples. Now, once the samples are in place, the gel box is gently closed and connected to the power supply. Running the gel at a constant voltage, typically between 60 and 120 volts, allows DNA fragments to migrate toward the positive electrode. The rate of migration depends on both voltage and gel composition. The thinner gels and lower concentrations allow faster movement, while thicker or denser gels slow it down. The longer runs improve separation between fragments, but if extended too far, bonds may migrate off the gel. As the run progresses, the tracking die shows how far the migration has occurred. A good stopping point is when the bonds have traveled about 3.5 to 4 centimeters, roughly 60 to 75 of the gel length. At this stage, the DNA fragments are well separated and ready for visualization under the UV light.
Finally, we visualize the results using a UV transilluminator. The gel is carefully transferred onto the UV transilluminator. The UV light then visualizes the DNA bonds, which will fluoresce due to the stain added earlier, allowing us to observe and document them. By performing this, it allows visualization of separated DNA fragments, helping us analyze their size and confirm the presence of DNA in the sample.
To conclude, gel electrophoresis is a fundamental technique that allows accurate separation and analysis of DNA fragments. Through proper preparation, loading, and visualization, reliable results can be achieved.